Hi class, so today we're talking about adding and subtracting polynomials, and you will find that it's very similar to the previous lesson of simplifying polynomials by collecting like terms. There may just be an extra step when it comes to subtracting polynomials, so I'll be basically going through a few examples and try to show you how I would do it step by step. Okay, so we'll start with adding. And the key to adding, or the key strategy, is to collect like terms. Okay, so you'll hear lots of math teachers use that phrase, collect like terms. Just a little strategy on how to organize your thinking when you're adding polynomials. So an example may look something like follows. Okay, so here's an example of adding two polynomials. The two polynomials are written inside of brackets, and there's a plus sign in between them. So we are adding polynomials. The first step is to ask, is there anything to do inside the brackets? Okay, is there anything to do inside the brackets? And you can look at one bracket at a time and see if there's any way you can simplify one bracket or simplify the other bracket. And you'll actually find that there's nothing to do inside either of the brackets. Because when we think about bedmass, we think about brackets first. So looking at the first bracket, there are three terms in there. One's an x term, the second one's a y term, and the third term is a constant term. So none of those three are considered like terms, so we can't really do anything to them. And it's the exact same thing for the second bracket. One's an x term, one's a y term, and one's a constant term. They're unlike terms. You cannot simplify them at all. So the answer to this question is no. There's nothing we can do inside the brackets. And if there's nothing we can do inside the brackets, then in this case, there's actually no need to have brackets at all. So I'm just going to rewrite all these terms, but without any brackets. Yeah, there's no need to have them. Okay, so that's the first step. The second step is going to be to collect like terms. So now I have 6 terms. Okay, it looks like I have a polynomial with 6 terms, and I'm going to look for any like terms. So I see 4x is the first term. So I look for any other terms that has the variable part of x. And I see that there is a positive 3x there. And that's it. Okay, so those are like terms. I'm going to look for more like terms. So the second term is plus positive 5y. And I look for any other terms that have a y as a variable, and I see negative y. So those are considered like terms. I've underlined them the same color. Now I look, the third term is negative 7, which is a constant, and I look for any other constants, and I see a negative 2. Okay, so I found 3 pairs of like terms. So what I'm going to do next is reorder these 6 terms with the like terms beside each other. So I will write the x terms beside each other, 4x plus 3x. And then I will write the y terms beside each other, 5 plus 5y, and then minus y. And then I will write the constant terms beside each other, minus 7 minus 2. So that's called collecting like terms. I'm just going to underline these the same colors I had them in the previous step so you can see where everything went. Okay, so that step is called collecting like terms. Now, the like terms can be simplified. 4x plus 3x makes 7x. And then 5y minus y makes positive 4y. There's The minus y is like minus 1y. And then the negative 7 minus 2 makes negative 9. You have to remember your integers. You start at negative 7, and you go even more negative by 2, you end up at negative 9. So this last line here is my final answer. There's nothing more to simplify there. I've got an x term, a y term, and a constant term. Okay, so that is collecting like terms. I'll do a second example of adding. So we may have something like this. Okay. So here's example 2. I'm just going to follow the exact same line of thinking. So the first step, is there anything inside of either brackets just by themselves that I can simplify? And this time, if you look carefully, there is. Inside the first bracket, there is 3x squared minus x squared inside that same bracket. Those are considered like terms. They both have the same variable to the same exponent. So we can simplify them. 3x squared minus x squared makes 2x squared. You have to remember the minus x squared is like a minus 1x squared. So 3 minus 1 makes 2. And then I'll copy down everything else. So I'll copy down plus 4xy. And then I'll copy down the entire second brackets. And I did check inside these second brackets if there's anything to simplify. And there actually is not. Okay, I see an xy squared term and then an xy term. Those are actually different because one of them has a squared on the y and the other one doesn't. So you cannot simplify that. Okay. So now at this point, now there's nothing to do inside the brackets actually. I've already simplified the brackets. So I don't actually need them. I'm going to erase them. And now I'm going to go through the collecting like terms process. So I'll start with the first term, 2x squared. So I look down the line and I ask myself, is there any other term that's got x squared as the variable part? And I look carefully and I actually don't see any. So there is no like term for that. So then I go to the second term. I'm using colors to distinguish the like terms here. So 4xy. So now I look down the line and I see, is there any other term where the variables are x, y with the exact exponents too? The exponents are 1. And I do see one. I see a minus 7xy. So I'll underline it the same color. And that's all I see. And then, so then I go to the next term, which is positive 6xy squared. And I look down the line. Is there any other term that's xy squared? No, there isn't. There's only one term left, and that's plus 8x. So when I look at this, there's only, there's 2 greens. And then the other 3, the blue, the yellow, and the red, they're all by themselves. So there's only 2 terms I can combine together. So what I'm going to do is I'm going to group them together. And everything else I'm just going to kind of copy down. So 2x squared I just copied down. Now the plus 4xy I'll copy down, but then beside it I'm going to write down minus 7xy because I'm grouping together the terms I underlined in green. And then I'll go ahead and copy everything else down. So plus 6xy squared and then plus 8x. This is just an organizational step. writing the like terms beside each other, it just makes it easier to add or subtract on the next step, which I'll do now. So this is going to be the last step where I combine any like terms. So again, it's only the green ones that are like terms, so everything else can be copied down. So 2x squared is just copied down. Now I work on my integers here, positive 4xy minus 7xy. So I go positive 4 minus 7. That'll end up at negative 3. And then you copy the variable part down, xy. And then I copy the yellow term down, and I copy the red term down. And this is the answer to this question. All right, so that's adding polynomials. You ask, is there anything to do in brackets? Once you take care of that, then I would underline like terms with the same color of if I have multiple colors to use, just to be organized and visually see what I'm going to collect together. I'll write the like terms beside each other to make them easier to add and subtract the integers. And I do that for the final step. Okay, so that's adding. Now we're going to talk about subtracting polynomials. And for our examples, you may have noticed we've been using integer coefficients for our examples. Generally, that's what we'll do. Technically, they can be any real number, but I want to keep things simple and use just integers. So when we're subtracting polynomials, you're going to have to be able to subtract integers. Okay, so you got to go back to the numeracy unit 1, and have that skill of subtracting integers. So I'll just add an instruction here. When we added polynomials, I asked, is there anything to do inside the brackets? And once you've done everything inside the brackets, we kind of just remove them. Now, when we're subtracting polynomials, you can't simply just remove the brackets. If there's a minus sign in front of a bracket, then that minus, when you remove the brackets, the minus sign has to be applied to every term inside the bracket. And what that does, it ends up flipping the sign of every term inside the bracket. So I'm going to write that down first, but then I'll write down an example so that hopefully you can see what I'm talking about. Okay, so if there is a minus sign right in front of a bracket, then when removing, I'll put that in quotes because that's not really a mathematically sound thing to say, to just remove the brackets. The negative I'll say -1 because it's really a -1. The -1 must be multiplied to every term inside the bracket. Okay, so I'll write an example to show you what I mean. Okay, so this will be my example. We still ask the starting question, is there anything to do inside the brackets, either brackets? So in the first bracket, there's an A term, a B term, and a C term. None of those are like terms, so we cannot simplify. And the same for the second brackets. There's an A, a B, and a C term. So no, we cannot do anything just inside the brackets. So then we remove the brackets, but following that rule I just wrote above, if there is a minus sign right in front of a bracket, which there is in this case, there's a minus sign right in front of one of the brackets, then when we remove that bracket, we have to actually multiply -1 because there's no number there, so we treat it as a -1. That -1 must be multiplied by every term inside the brackets. So these are multiplication symbols here, multiply. So I'll show you what that looks like. The first bracket, you can just remove it because there's no minus sign right in front of it. Okay, so the first bracket can just be removed. But the second bracket, when we remove it, every term inside gets multiplied by -1. So the first term, -2a, when you multiply that by -1, what's -1 times -2? It's +2. So the -2a turns into +2a. Okay, the next term, plus 3b, must be multiplied by -1. So 3 times -1 is -3b. And then finally, the minus c must also get multiplied by -1. So -1 times -c becomes +c. A negative times a negative is a positive. So essentially, what happens is when you subtract polynomials, the second brackets, the one after the minus sign, all of the signs get flipped. The -2a became a +2a. The +3b became a -3b, and the -c became a +c. That's the effect of that minus sign. It flips all the signs in that second bracket. Okay, now we can go on and do what we did before, just when adding polynomials. Look for like terms. Do it quicker this time. I have 6a and 2a. Those are like terms. Underline them blue. I'll use green for the next like term, so -10b and -3b. Those are both b terms. And then finally, plus c, I'll use yellow. Okay, I'll group them together. So I'll group the blues together. Then I'll group the greens together. This is called collecting like terms. Now I'll collect the yellows together. Now that they're all collected together, it's easier to see what I'm adding and subtracting. And again, I'm going to be using integers for most of the questions just to keep things simple. So 6a plus 2a, that'll make 8a. And then -10b minus 3b, that goes to -13b. And then plus c plus c. So these are considered 1c's. So 1c plus 1c is positive 2c. And that is the answer. All right. So then I'll do one more example, I think, just for repetition. Try to drill these concepts in. Okay, so let's see. I'll say okay, so I've decided to put 3 polynomials this time. And there's a minus and a plus in between the polynomials. So we'll put all the skills together. Okay, is there anything we can do inside of an individual bracket? The first bracket is no. X squareds cannot be just added to x's. You can't simplify that. The second bracket is also no. X's cannot be subtracted by regular numbers. Those are unlike terms. And the third bracket is also a no. An x squared cannot be subtracted by a regular number. So there's nothing to do inside of the brackets individually. Now we will remove brackets with the caveat that if there is one that has a minus sign in front of it, we do have to take that into account. And there is. Okay, I'll circle it. There's a minus sign there. So that's going to affect the terms inside that bracket when we remove the brackets. But the first bracket, I can just remove it. Okay, now the second bracket, the 4x needs to be written as minus 4x. And then the minus 5 needs to be written as plus 5. So that is the effect of multiplying each of those terms by the negative 1 that's in front of it. Now the third bracket can just be removed with no changes because there is a plus sign in front of it. And if there's just a plus sign in front of it, you can just remove it. You don't have to make any changes. Okay, now I will look for like terms. So I see the first term is an x squared term. I look down the line for any other x squareds, and I'll underline them blue. The next term is plus 7x. I look down the line for any other x terms, and I underline them the same color, green. And then the next term is just a constant, plus 5. So I look for any other constants, and I see a minus 4. I'll underline them yellow. Okay, I'll collect up the like terms together. So the blue ones I'll write first. And then I'll write the green ones next. And then I'll write the yellow ones next. And now I'll do the adding and subtracting of integers. So the blues, negative 6 plus 1 makes negative 5, x squareds. Now the greens, positive 7 minus 4 ends up at positive 3. And now the yellows, positive 5 minus 4 ends up at positive 1. And this is the answer. Okay, so that's how you add and subtract polynomials in a really broken down step-by-step way. Some of you may be able to skip some steps. For instance, the third step, or the second step here, where you just rearrange the terms to collect the ones beside each other that are like terms. Some people don't really write that step, and you don't have to if you don't want to. I'm just writing it here to, if it's your first time, just to help you see what collecting like terms looks like. All right, so that's it, and we'll assign some practice work for you to do.